Hmm?
Add 6.
Add 6 and then what? How can we get p by itself in a...
You add 6 first and then divide it.
But if we minus p, then we're separating them. We only want to try to get 1p. What's your idea? I want to hear the long shots. I want to hear the Hail Marys.
Plus 6 to
Okay.
the other side, and then GCF for 2 P's. So it's going to be P and then move the 6 back so we have P and 6.
But when you move it back, the 6 won't go in parentheses with anything. It'll be outside the parentheses. I like where you're going, though.
Do P minus P.
But we can't. They're not like terms.
Oh, okay.
Robert?
Okay, so add 6 and then leave the P in the GCF or the P's and then we put the third P on the outside.
Okay, but then, think about yesterday or Tuesday. What did we have to have? Oh, what did we have to have on one side on Tuesday in order to be able to do what Robert's suggesting? 0, but you have a 6. We can't do it when there's a 6 over there.
Well, then we can do
Do we do that trinomial?
We factor it. How do we factor this? So what you guys were saying, there is another method that we are going to learn in the next unit that would have you move this 6 over. But we're not there yet. Okay? Because you have to move it over, then you have to find a new value, and there's a formula to find a new value that gives you a trinomial that you factor. But that's next unit. We're not worrying about that right now. So for right now, if you see a trinomial and it's equal to 0, you're going to factor it to try to solve it. So how can we factor p squared plus p minus 6? P minus 2, p plus 3.
Where did you get 3?
Because we're looking for two things that multiply to negative 6. And so when we do, if you make the 2 negative and you check it, you have 3p minus 2p gives us our 1p that we want. Okay, so once it's factored, what did we do? We set each thing being multiplied equal to 0. And solved. So we'll get 2 and negative 3. But what is it asking for? So these are x-intercepts. So how could we write 2 as an ordered pair? 2 comma 0. And then negative 3, negative 3 comma 0. Okay, so this is kind of, this part right here is what 10.6 was having you do. Today we're just going to take it and put it in terms of graphing, so it's an ordered pair as opposed to just 2 values. Okay. If we look at number 2, do we have to factor number 2? No, why? It's already done. Okay, so what are the things that are being multiplied? So here we have 3 things being multiplied. The negative 1/2, the x minus 3, and the x minus 6. Now, the negative 1/2, does it have a letter that we would need to solve? No, so we don't need to worry about setting that equal to 0, because negative 1/2 can't equal 0. So we're only going to solve or set equal to 0 the ones that have an x that needs to be solved. So the reason why on the 22 and 23 and 24 from last night is because the outside thing, the GCF, had a letter. That's why we had to set that equal to 0. If it's not, no letters there, you don't have to. Yeah.
So basically, any number it is will not matter. Unless it's 0, but it's not really.
Oh, you mean on this side?
On the other side. Like 1/2, 2, and 9 really will make the 0.
The only time it'll matter is like the one, I think it was 22 that we did for Chase here. It was like d times d minus 5. that's not just a number, so we have to set it equal to 0. So if you have a letter out there as a GCF, then you have to, but if there's no letter, no. Okay, so then when we solve each one, we'll get x is equal to 3 and x is equal to 6, but again, we need to write ordered pairs. So how can we write these as ordered pairs? 3, 0, and 6, 0. Okay, any questions about that?
So you don't do anything with the -1/2?
Nope. Because if you were to set it equal to 0, like the other things being multiplied, you'd get this. Is there anything to solve for? Can -1/2 ever equal 0? So you just cross it off and ignore it. Okay, so if you look at your 10(7), this right here is what you're doing on 1 through 6. So are there any questions about how we did 1 and 2? Because that's how you're doing 1 through 6. You're going to factor, solve, and write as an ordered pair. Okay, if you look at 7 through 12, what is it asking for on that one? Y-intercept. So how do you find a y-intercept? You put 0 in for x, and then you'll get your answer as an ordered pair. Okay? So I want to jump down to how you're going to do 13, 14, and 15, the graphing. Okay, so we're going to do 2 graphing problems, so that way you guys you know how to graph them. And we're going to find the x-intercept, the axis of symmetry. Do you guys remember what that is? The x value of the vertex, good. And then we're going to find the vertex, and then the y-intercept. So let's start with the x-intercepts. How can we start by finding the x-intercepts here? What would we do? Factor. Okay, so let's try and factor this. X squared will become x times x. 2 things that multiply to 15. Plus 5 plus 3. Set each factor equal to 0. And solve for x. So we have -5 and -3. So when we write them as ordered pairs, -5, 0, -3, 0. So that first step is the same thing we just did on 1 and 2. So I'm going to go to my graph. And I'm going to plot -3, 0, and -5, 0. My x-intercepts. Are you with me so far? Now, next thing, axis of symmetry. It's going to be x equals something. Well, what do we remember about parabolas? They're U-shaped. They're also symmetrical. So, where do I know my axis of symmetry has to be? Right in the middle, because that's how we found points, is we would go 1 or 2 to the right, find it, and then reflect it. So that means our axis of symmetry has to be right in the middle of these 2 points. So what x value is right in the middle? -4. There's your axis of symmetry. So I'm going to draw mine just so that I remember that it's on there. And that axis of symmetry, as Robert stated, is the x value of our vertex. So now we need to find the y value of the vertex. So how might we go about finding the y value? Perfect. We just plug in -4. So we're going to take -4 squared plus 8 times negative 4 plus 15. And instead of 0, I'm going to change it to a y, just so that way I get a y value. Because this was 0 because we're finding the x-intercepts. We go back to y to make it a generic y. Let's see, so we'll get 16 minus 32 plus 15. So let's see, that's 31. That'll give us negative 1. So that means our y-intercept, or I'm sorry, not our y-intercept, the y value of our vertex is negative 1. So I'm going to go negative 4, negative 1. And that point should be somewhere on that dotted line you drew. Now the last thing it wants us to find is the x, or the y-intercept. So how could we find the y-intercept?
Just plug in 0
For which one?
for x.
Plug in 0 for x. So again, instead of 0, I'm going to put y, and then I'll plug 0 in for x. And what do we get for the y-intercept? 15. So 0, 15 is our y-intercept. Now that's not going to fit on my graph, so I can't really plot that because it's not really big enough. Mine only goes up to 8, so I'm not going to plot it, but I am just going to write it there. So then I just need to come back and connect my dots to sketch my parabola. And there you've graphed it from factored form. So one of the biggest differences between graphing from vertex form and factored form is in vertex form we start with the vertex and then find 2 points. In factored form we find 2 points and work backwards to find the vertex. Okay, they both give you the graph, they're just different forms and ways to do that. So any questions on how to graph in factored form? Because I think you have like 2 of these on your test where you have to graph in factored form, and there's like 2 that graph in vertex form. Ryan?
When finding the y-intercept, will you always plug in 0?
Because that's what by definition what a y-intercept is when x equals 0.
For 7 through 12.
7 through 12, you're just doing what we did here in orange.
Yeah.
That's what 7 through 12 is. Just find the y-intercept. All right, let's do number 4. So again, we're going to graph in factored form. Make it a little bit bigger. So let's start with the x-intercepts. Okay, so how can we factor p squared plus p minus 6? Good, someone noticed it's the same one as number 1. So I'm just going to go up to number 1 because we already did the factoring up there. And so we know that our intercepts are 2 and 3, negative 3. So 2, 0, negative, oops. I hope I put my parentheses. 2, 0, and negative 3, 0. So if you want, you can make yourself a little note, like to say, see, work on number 1. So then we're going to go to our graph. So let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. Okay, so if we plot our x-intercepts, we have 2, 0 and negative 3, 0. So now we need to find the middle. So what is right in the middle of these 2?
X equals
Negative 1? So usually one of the easiest ways to do it is just to count your way in. So if I go 1 in, I go 1 in, I go 1 in, I go 1 in. Right now I'm at negative 1 and 0, but I'm still not meeting. So what's in the middle of 0 and negative 1? Negative 1/2. So negative 1/2 is going to be where my axis of symmetry is. So what's really common, and it might be what you did, is you skipped over 0. And that's really common, but we have to remember 0 is still a spot. So we also know that negative 1/2 will be the x value of our vertex. So how do we find the y value that goes with it? We plug it in. So we'll have negative 1/2 squared. No, we won't. Yeah, we will. Plus 1/2, negative 1/2, minus 6 equals y. Negative 1/2 squared is 1/4. Using your powers, you can just square the top, square the bottom. Those are your exponent rules. Plus negative 1/2 minus 6. And then what might we need to do in order to be able to add these together? If we have fractions, what do we have to have? Common denominator. So what would our common denominator be? 4. So this I'll leave as 1/4. This one will become negative 2/4. And this one will become 24/4. So all we have to do now is add the tops, because the bottom's going to be a 4. So 1 minus 2, that's negative 1, and negative 1 minus 24 will give us negative 25. What is, and this might be where you want to figure out what is in decimal form negative 25/4. 6.25. So we can also write this as negative 6.25, because that's sometimes a little easier to graph than fractions if fractions aren't your thing. So if I go down 1, 2, 3, 4, 5, 6, and then a little more, we have the vertex. Now what about the y-intercept? That's the last thing we need to find. So if we put 0 in for p, what are we going to get for y? Negative 6. So 0, negative 6 will be our y-intercept. So I can come over here and plot that, and then connect the dots. And you have your parabola. You won't get a lot of them that have a fraction for your axis of symmetry, but it can happen. I think all of them on your assignment come out to nice whole numbers, but just know that it is possible for your axis of symmetry to not be a whole number. In fact, more often it's not going to be. We've just given you guys the nice ones. Okay? This is what you're doing on 13, 14, and 15. You're finding all these 4 pieces and graphing. And then if you look at 16, 17, and 18, you guys are going to do kind of like what you did on 10-6, where you changed it from standard form or vertex form to standard form. And then you're also going to change standard form to factored form. And you're going to do that on 16. Then you're going to find the x-intercepts and the y-intercepts by just substituting 0 in for x and 0 in for y to fill in the table. So go ahead and take about 20 minutes or so to do as much of worksheet 7 as you can.